Remember, during the Proctor compaction test, we are trying to establish a certain indicator of what would be acceptable compaction on site. That indicator would be the maximum dry density. And in the construction specification, we will be provided with the requirement on how much achievement need to be made on site in order to comply with the specification. So like I mentioned before, it's 90% or 100% even, depending on what kind of compaction work you do the soil compaction for. If you go back to the Proctor compaction test, remember we did at least 5 compaction work in a mold to produce points for us to draw or to establish the maximum dry density and optimum moisture content chart. Which will be referred to in order to comply, in order to ensure compliance of our site work. So in this case, let us just go through one simple example. In this case, the soil that has been compacted into a mold. This is, we're talking about a Proctor in the lab that will be used as a benchmark. The compacted soil in the mold is 3762 kilogram per meter cube, and so on until with the information on the mass of tray. Mass of tray is the tray for sample for moisture content, and the moisture content, the wet soil and the dry soil. Remember, after we compacted the soil in a mold in the lab, we will weigh it to get the density. At the same time, we take sample, put in a small tray, and weigh them again to get the weight before it is dried in the oven. And then after we put in the oven, we wait again to get the dry sample. From there, we can establish the water content. Is W here, right? So in this exercise or example, it says compute gamma dry and water content. So water content is straightforward. I already mentioned just now. You take sample, weigh them, put in an oven, come out, weigh again, then you get the difference. That is the percentage of you can get the percentage of water inside the sample. The gamma dry, there will be some calculation. I'll show you. And the second one is calculate 80% saturation line and 100% saturation line using specific relativity of 2.69. Later on, we'll look into that. And finally, of course, this is what we are looking for: the maximum dry density and the optimum moisture content, the MDD and the W naught, which is the optimum moisture content. That will be used as a reference value for our result from field density test that we do on site. So I mentioned before the water content is very straightforward. The mass of wet minus mass of dry divide by the mass of dry multiplied by 100%. Then you will get the percentage of water inside the sample. And then dry density. Okay, dry density in the lab. We're talking about the lab now. Dry density in the lab is, first we need to find what is the bulk density, which is the weight divided by volume. The volume in the lab is straightforward, I mentioned, because the mole, this is the volume of the mole. We know the mole volume, we can measure them, the diameter and the height, and we get the volume. But to calculate gamma dry, we use this formula, which is gamma dry equals to gamma, which is gamma, the wet density, divided by 1 plus the moisture content that we have just established just now, from the difference in the before and after it goes into the oven, and divide by 100. So we will get, in this case, for the first specimen, the dry density is 17.22, right? So we need to do this calculation 4 more times to get, remember, to establish the 1, 2, 3, 4, 5. To establish this maximum density. So we will calculate the remaining dry density using the same formula just now, to get the value of dry density, and then that is sufficient for us to plot the chart. And then on the chart, there is also a need to provide what we call the 80% saturation line and also 100% saturation line. And because this information not only tells us about the what I call the sensibility of the result, or the chart, and the result and the chart that we have drawn later, because this will indicate, it will be able to tell us about whether the test that we have carried out makes sense or not. But that one will be in a separate discussion on that matter, because the location of this 80% and 100% line can give some indication on whether the test that we have carried out is supposed to represent the actual condition of the soil, or there are some errors. That discussion I will include in the reading material. Okay, how to get the value to draw this line? It is from this formula, right? For this 80%, and for this is for 80% down here. Basically, we need what would be the water content 80%. What is where to plot this on the left? Remember, on the left is density. On the right, on the x-axis is this water content. So we would like to find out where is the percentage of 80% moisture content in the soil, or where is the point of 100% density when water is 100%. Okay. So we use to do that, we usually use 3 points here, the gamma dry of 16, 18, and 20 to plug into this formula. And then from this formula, we'll be able to locate where would be the moisture content. So for example, for zero air void, this is the formula. The gamma of water, which is, gamma of water is 1. Gamma of water, the percentage of water from 16, divide G, the specific gravity. And then we will get the first point for the 16. And then we get for the 18, and then we get for the 20. Then we can draw a line. Same thing here. For 80%, we will multiply by 80%. Same thing here. 9.1 is the density of water, the unit weight of water, 9.1. You can use 16, and then this is the what they call specific gravity. So the point is at 19.3%. So if we do this for the 80% and 100% fully saturated, we will get this table. From this table, the gamma dry is 16, 18, 20, and the 80% saturation line will be at 19%, 13%, 9.5%. For 100, we have 24, 17, and 11. Then we plot them together with this chart, right? So this one here we have got from the 5 tests just now. This is the 80% curve. This is 100% curve. Okay. One way to check the result of our Proctor test in the lab is to look at where does the 80% curve cross this maximum dry density curve of the various points. Usually it will cross near the peak of this chart over here. So no, you can see it crosses. So this is one of them. There are a few more indicators that you will read in my handout that will you will get to see whether your result is sensible or not. So once we have got this, this is usually included in the report to be submitted to the authority who will monitor the construction on site. From here, you will find what is the optimum moisture content and what will be the maximum dry density. So the maximum dry density over here is about 19. The optimum moisture content is 11 point something. So the 19, the dry density 19 will be the reference density to be referred to according to the specification. If the specification says 90% compaction, that means 90% of the 19.